My name is Gregory Grigoropoulos. I'm professor at the National Technical University of Athens and the director of the Laboratory for Ship and Marine Hydrodynamics. The laboratory is a major testing and computing facility operating since 1979 within the School of Naval Architecture and Marine Engineering. The experimental capabilities of the laboratory are based on an industrial-sized towing tank, which is 100 meters long, 4.6 meters wide, and 3 meters deep. The towing tank has a paddle-type wave generator for producing regular and random waves at one side, at one end, and dumping shore at the other end. Towing carriage runs at speeds up to 5.3 meters per second. The laboratory is involved in education for under and postgraduate students, research in the area of ship and marine hydrodynamics. It offers services to the Greek shipbuilding and shipping industry, services to Hellenic Navy and the rest of public sector, and services to clients from abroad. Scientific activities. They include encompass sea propulsion, resistance and self-propulsion, seakeeping performance, maneuvering, damage stability experiments, hydrodynamic design, analytical and experimental analysis of wave climate, computational hydrodynamics, CFD, advanced experimental techniques, and in situ measurements on board of ships and large-scale models. We are producing results for passenger comfort, ship maneuverability, seakeeping performance, and wash-wake effects. Towing tank experiments, they include calm, water, regular and random waves tests, hydrodynamic design of conventional ships, design of hull forms, bulboard bows, sponsons, anti-rolling devices, appendages, etc. Model ship, fast and planing ships, single hull and multi-hull vessels. Also the design of ship propulsion systems. Sailing yachts, experiments using a 5-component balance. Floating structures for sustainable energy production on the basis of solar, wind or wave energy. We have our own model manufacturing workshop and a fully equipped electrical and electronic workshop. Regarding the marine environment, we carry out studies and computations, calculations for wave propagation, wave-bond interaction problems, hydroacoustics, wave energy, stochastic modeling of the environment, autonomous vehicles, and atlases of wind and wave distribution.
My name is Spiros Mavrakos. I am Emeritus Professor at National Technical University of Athens and former Director of the Laboratory for Floating Structures and Mooring Systems in the School of Naval Architecture and Marine Engineering. The laboratory is currently directed by Professor Yannis Hadjigeorgiou, Vice Rector of Research and Lifelong Education. The laboratory was established in 2005 by University Senate decision and by governmental decree in 2009. Its main objectives are the teaching, research, as well as consulting activities to the industry in the scientific field of floating structures and mooring systems, which are associated with a broad spectrum of economic activities and applications, as for example to offshore structures for oil and gas exploitation and exploration from the marine environment, marine structures for offshore renewable energy exploitation, including wind and wave energy, as well as hybrid solutions, analysis and design of several types of mooring systems and slender marine structures, infrastructures for residential, tourism, industrial, and sustainable energy development in coastal and offshore waters. The educational activities of the laboratory include teaching of 3 undergraduate and 6 postgraduate courses, as well as the support to several diploma theses and doctoral dissertations. As far as key research areas are concerned, they include development of methods and numerical algorithms for the linear and higher order hydrodynamic body-wave interaction phenomena using analytical and numerical methodologies. A second research area is the investigation of body-wave interaction in the presence of a marine current as well as hydrodynamic analysis of floating structures advancing with low forward sweeping waves. A third focal research area is the analysis and design as well as the efficiency evaluation of several types of wave energy converters and floating wind turbines for renewable marine energy exploitation. A fourth research area includes the development of methods and numerical algorithms for the static and dynamic analysis of mooring systems, risers and slender marine structures. And finally, the investigation of motion response analysis of moored marine structures in the open sea and in harbors areas. The laboratory has participated in several European and national competitive research programs, in some of which acting as coordinator. The laboratory offers also specialized consultant services to the industry in areas of hydrodynamic analysis of several types of marine structures, cable-laying vessels, as well as of special purpose floating structures with indicative applications to the deployment of scientific equipment, fish farm cases for open sea applications, the design of oceanographic buoys, and finally to the mooring line analysis and design of moored vessels.
Hello, my name is Nicholas Tsouvalis and I am professor at the School of Naval Architecture and Marine Engineering of NTUA and director of the Shipbuilding Technology Laboratory. The laboratory was established in 1975 and its basic objective is the research on engineering materials and on the structural design and fabrication parameters that influence the performance of marine structures. This objective is achieved through educational and research activities, as well as through providing specialized engineering services and technical consulting to the industry. The educational activities of the lab include teaching of 7 undergraduate and 4 postgraduate courses, as well as the support to several diploma theses and doctoral dissertations. The laboratory consists of 4 units: the Tests and Measurements Unit, the Materials Characterization Unit, the Structural Analysis and Design Unit, and the Processes Unit. All these lab units are supported by a fully equipped machine workshop. The research activities of the laboratory are focused mainly on the following topics. First, structural analysis, design optimization, and structural health monitoring of marine structures, employing various design and structural analysis software and a 76-core computer cluster. Second, welding science and technology, employing equipment like a welding robot and welding machines for various welding methods, including friction stir welding. Third, material science and technology, including thermal treatments, corrosion and protection of metallic materials and failure analysis, and employing equipment like a scanning electron microscope, XRF analysis, optical microscope, macro and micro harness testers, electrochemical instrumentation, a salt spray chamber, and surface characterization equipment. Composite materials and hybrid metal to composite adhesive joints, employing special equipment for manufacturing composite materials products. Fifth, destructive and non-destructive testing of materials and structures, employing 2 universal hydraulic testing machines, a multi-channel data acquisition system, and various equipment for ultrasonic non-destructive testing. Finally, design and implementation of full-scale in-situ tests for monitoring the structural response of large structures. The Shipbuilding Technology Laboratory participates in several European and national competitive research projects, in some of which acting as coordinator. The lab offers also specialized engineering services to the industry in areas like the structural design and analysis of marine structures using numerical simulation methods, destructive and non-destructive tests and quality control of metallic and composite materials, failure analysis of marine and mechanical engineering parts, and finally corrosion and protection design for metallic structures.
I am Dimitris Liridis. I'm the Director of the Laboratory for Maritime Transport in the School of Naval Architecture and Marine Engineering of the National Technical University of Athens. The School of Naval Architecture and Marine Engineering has several laboratories. One is the Laboratory for Maritime Transport. This was informally established as a research unit by Professor Harilaos Psaraftis in the 90s, and it has been established as a formal laboratory in 2006. It has two faculty members, Associate Professor Nikos Vendikos and myself, who is also the director of the laboratory. We have one special research and teaching staff, 10 PhD students currently, 7 research staff, 1 administrative staff. We offer 8 undergraduate courses, 3 graduate courses, and up to this day we have completed in the lab more than 8 PhD theses, 250 diploma theses, 70 projects, state and private, funded either by the EU or the Greek state. We have handled more than 15 million euros and more than 10 million euros have ended in the Laboratory for Maritime Transport. This is work that has been done partly also by Professor Psaraftis, that he was the director of the lab until 2013, that he left the university. Our indicative research areas include, except of course for education and training, modeling of the shipping market, also based on artificial neural networks. We do also offer research and expertise in financial engineering, company valuation, financial risk management, statistical arbitrage, life cycle cost calculation and life cycle analysis, supply chain optimization and intermodal logistics. We have a lot of work done in regional development, including support for large infrastructure projects in terms of project development, funding, project finance for vessels, ports and energy. We have a lot of work in policy such as maritime clusters, commercial policy and regulatory framework, environmental analysis and air emissions. We have also 2 important areas that have been in the specific expertise of Professor Nikolos Vendikos. These are safety-related and risk-related topics associated to the maritime safety, the environment and the human factor. Indeed, we are trying to be in the elite of the research units worldwide, expanding our efforts towards resilience engineering and maritime sustainability analysis with a focus of innovative and disruptive technologies. Our portfolio is getting stronger by the day, especially in the studies of economics, finance, energy, safety, human factor, all the areas I have already mentioned, and especially new systems in the areas of offshore and gas industry. For more information, you can visit our webpage at www.martrans.org.
My name is John Prousalidis and I am the Director of the Laboratory of Marine Engineering of the National Technical University of Athens, in the premises of which we are right now. Marine engineering is one of the major scientific sectors of the School of Naval Architecture and Marine Engineering, which are ship design, that is to say the theoretical design of the ship, hydrodynamic, which comprises the study of the interaction of the vessel with the seawater, marine engineering, of course, which deals with the study of the main ship propulsion system, the most expensive and critical equipment on board, as well as all service loads, auxiliaries and the associated energy networks assisting the ship to accomplish her mission. And finally, shipbuilding, which comprises the studies of the materials and methods of constructing a waterborne vessel. Focusing on the marine engineering primary objective, this is the analytical study and testing of the coordination between the propulsion engine and the propeller. The premises of the Laboratory of Marine Engineering comprise, among others, a test bed where propulsion engines and other systems can be tested via measuring methods of high accuracy. This is the control room of the test bed, which is soundproof as the noise is pretty annoying when the engines operate, beyond, let's say, 110 dBs. Moreover, the experimental results of the system examined in the test bed can be confirmed via theoretical analysis tools too. During the last 3 decades, the laboratory under the direction of the previous directors, Professors Kyptatos and Ioannidis, had contributed to the development of propulsion engines, which have been used in most ships and has been recognized among the best laboratories of this category worldwide. Furthermore, taking into consideration the modern challenges for decarbonization via alternative fuels and green shipping in general, the Laboratory of Marine Engineering has started being properly transformed. Within this context, testing equipment for electric propulsion and hybrid electric propulsion systems have been integrated, while a new engine using methanol as a fuel has been installed.